Assalamualaikum and good day, student. Continue with chapter 3, lecture 12. We will focus on the absolute motion analysis. On the relative motion analysis, velocity and acceleration, we will discuss later. What is the approach in absolute motion analysis? So the approach is actually by making use of geometric relation on the rigid body, and then by having the time derivative of the geometric relation, you will be able to obtain the velocity and acceleration of the rigid body. Okay, let's take this example. If the blue color is rotating clockwise, so the disc will be moving to the right hand side. The disc is having the angular velocity of omega, and then the angular acceleration of alpha, with a radius of r. And then if you look at this point C over here, at the time when the disc is moved within a distance of s direction, so point C is already repositioned according to this picture over here as a C prime. So the basic equation that you should know is S is equal to r theta. So the distance traveled over here of the point C is actually S equal to r theta, and then this is the normal equation that you should know, V equal to r omega, and then A is actually r theta, right? Alright. Let's see how we can define the position of C prime, giving that this is the axis of X, and then this is the axis of Y. So how to define the position of C prime? Okay, this is, if this is, we know that we can know as r sine theta, is it? Because this is given already the theta. So this distance is actually r sine theta. So what is the left over here? I mean the distance of here. So x, this one I call it x. So x is equal to s, the distance over here, minus r sine theta. So this is the position of C prime at x. So it meets this equation over here. And then you know that S is equal to r theta. So we arrange back the equation and become like this. So x is actually r theta minus r sine theta. Okay, let's see the y position. So we know that this is r cos theta. Then the distance from the center of rotation to here is r. So y here, so y is actually following this equation. Y is equal to r minus r cos theta, and then we simplify the equation. So that is the position of a C prime represent in x and y coordinate system. Okay, if you remember that the approach of absolute motion analysis is by making use of geometric relation, and then by having the time derivative of the geometric relation, we'll be able to obtain the velocities and acceleration of the rigid body. Let's take this equation on the x direction first. I mean on the x position, on the x position of a C prime just now. Okay, after the time derivative of this equation, you'll be able to reveal another equation like this, where this is the r theta dot, because we are having a time derivative of this equation, r theta dot minus r theta dot cos theta, and then you know that the r theta dot is actually v, velocity. Alright, the next one, you have to understand on the calculus, the time derivatives of the calculus, where f g plus f prime g. So this is the rules of the time derivative of the equation in calculus. We have to do some revision on that one. Okay, this is time derivative of this equation. It reveals the x double dot, r theta double dot, and then we rearrange the equation, and then again you rearrange the equation, and then you notice that the theta double dot is actually angular acceleration, and then theta dot is actually angular velocity. By having that, you know that it's actually r alpha. R alpha is acceleration of the to the right hand side, just now, the tangential acceleration, and then r omega over here, so you maintain it. So this is actually theta x double dot. Okay, now let's see on the y position or y direction. So this is from the previous position coordinate of y of the C prime, and then by having the time derivative of this equation, you'll be able to reveal another equation, which is this one, and then you do another time derivative of this equation, you'll be able to reveal the another equation where this is the acceleration of the at y axis. So to simplify again, do the simplification. So you get the, again, this is r theta, r alpha is equal to acceleration, and so this is the y double dot, where y double dot is representing as the acceleration of the point at C prime at y axis. Okay, let's see the where is the position of C. This is point O. This is point O, and then this is point C after one complete rotation. One complete rotation. Okay, alright, let me see. Okay, so this one is actually one complete rotation, so meaning that this graph is representing 2 complete rotation of the disc. Repeat again. The red color is representing point C, while the blue color is representing the point O. You notice that in XY positioning, point O is remain at the center, while point C in the starts, it start from 0 and then it's climb up until reach the maximum, where this is the position of like say this is C, and then it's coming back to over here, C here, probably here, okay, C 1 2 3, and then the last one, it goes back to the original position at here, while the point O is still maintaining at the center radial. That is the idea. Okay, this is another good example on how the absolute motion analysis is being applied to study the window omega and alpha, the omega of the window, I mean the angular velocity of the window panel, having this is the hydraulic cylinder pushing up the window panel. So you have to very familiar with this kind of cosine equation, where if I can extract this one, it's actually, if you are studying the let's say the hydraulic jack is having a certain velocity over here, moving at a certain velocity to open up the window, let's say, and then at an instance the degree is given as theta over here, and then dimension of the window is given, and then the opening of the window dimension is given. So this is the S. So from this equation, what we can have here is something like we can say that we are concerning about this. So S squared is actually this is B is actually, we call it this one, so 2 squared plus C, let's say this is a C, so 1 squared minus 2, again B is 2, so C is 1 over here, 1, and then cos theta over here. You remember that the absolute motion analysis is the making use of geometric relation, and then by having the time derivative of the geometric equation, you will be able to obtain the velocity and acceleration. So let's say we have over here is the equation, okay, to simplify is S squared minus 255 minus 4 cos theta. Okay, let's see, this is the equation. So what you will have here is you do the time derivative of this one, you'll be able to reveal the velocity of the window of the hydraulic jack, and then by having the time derivative of this equation also, you will be able to reveal the omega, I mean the angular velocity of the window panel over here. So that is the important to study. Using those cosine rules over here, you'll be able to reveal the study window omega and acceleration. Okay, alright. On the later class, we will do some a bit of a tutorial to further understand what is the absolute motion analysis all about. Thank you very much.